Jai Hind everyone, this is Chelsi Sen, AKGC IT department. Today we are going to continue the series of DBMS in which we are going to discuss the relational algebra. Relational algebra is the most important topic for the exams and it is very important for the GATE also. So today we will discuss about the relational algebra and we will discuss various operations how the relational algebra is going to use. So talking about the relational algebra, it is a query language in which the user requests the information from the databases. It have the various categories. We used to discuss the various language in the DBMS. One is the procedural and the other one is non-procedural. So talking about the relational algebra is a procedural language. So we going to discuss about the relational algebra and in the case of pure languages, it determines the theoretical portion and the notation portions. That's why we are called as a pure languages, in which the query don't execute, but it is used in the theoretical portion. For the practical implementation part, we use the SQL. So the talking about the pure languages, it is the relational algebra, and we are having the calculus part. And in the calculus, we are having the two different parts, that is the tuple relation calculus and the domain relation calculus. But today we are going to discuss only the relational algebra part and the various operations of the relational algebra. Let's discuss about the relational algebra. Relational algebra is a procedural query language. It gives us the step-by-step process to obtain the result of the query. It uses the various operators to perform the various queries. So let's discuss which type of operators in the relational algebra are. So these are the various types of operations in the relational algebra. We are having the select operations, we are having the project operation, union, set intersection, set difference, Cartesian product, and the rename. These are the mainly operations used in the relational operation. So like in the SQL queries, we are having the various commands like select command, create command, and many more. We can use the same operation in the SQL part also. But in case of the relational algebra, it determines the different notations. So one by one, we will discuss all the operation and we will discuss all the notations of the relational algebra. Now, talking about the first operation, that is the select operation. Select operation is similar to the part as we have used in this SQL part. In the SQL, we used to write like the select command and we used to write star and from the table name. This is how we're going to represent in the SQL part. But in case of relational algebra part, we used to denote it by the symbol that is called as the sigma. We use the select operation by using a command that is the sigma. One more thing, in the select operation, it selects the various tuples. Tuples is called as the row, or we can say as the records. So it selects the particular rows or the records which satisfy the given predicate. Predicate defines as the condition. These are the various terminologies we used in the DBMS. These we have already discussed, like the tuple, domain, predicates. These are the various notation. Talking about the denotations or the notation of the select operation, this is the notation. This is how we are denoting the select operation. We are having the sigma symbol which selects the particular tuples, and we are having a predicate from the R table. So sigma is used for the selection part. Whatever the tuples, whatever the rows we want to select, it will select all the rows. Then R is representing as a relation. Which table, from which table we want to select the data. It is relation is denoted as a table. Now, then we are having a P. P is called as the predicate, or we can say that it is a condition, or we can say that it is a propositional logic, which may use various operators or connectors like and, or, not, and various relation operators like the comparison symbols, greater than, less than. These are the various symbols we can use for the selection part. So This is the denotation part for the select operation. Very important thing about the relational algebra is about the denotations. So this is how we are denoting the select operation. Let's discuss it by the example. This is the following table, and we want to select any particular branch. We want to select a branch name. We want to fetch the data of a records which having a branch name is equals to parite. So let's sigma is denote for the tuples. What we want to select means whatever the records are there, that will be going to be as an come as an output. And over here we had given a condition, that is branch name is equals to this. You can give any condition, and loan is called as the table name. Over here we had given the specific table, whichever table you want the data, you are mentioning the data over here. So this is how we are denoting sigma. We had given a condition, that is a predicate, and we had given a relation. This is how we had given sigma, predicate, and this is the R part. And we had used the various operators like the comparison equal operators. As an output from this data, we get this particular data whose branch name is parite. So this is how the all records come as an output. So at the backend, it is a procedural language which works behind the SQL part. Now discuss about the this is the one more example of the select operation. This is the table relation R. Over here we had given a condition, and as an output we got this particular thing. So these are the various examples. Now in case of tuple relation part, it is over here we are denoting it as like this. This we will discuss in the further lectures. We will going to discuss this particular thing in the next coming series, tuple relation calculus and the domain relation calculus. Now talking about the project operation, this is the second operation of a relational algebra. It shows the list of attributes. Those attributes which we want to appear as a result. For example, we want only 2 columns as an output, then we can give the particular column name or an attribute name as a result. So that's why we use the project symbol. So for that we are using the denotation part, that is the symbol is denoted by the pi, and then the notation is going to be pi, and whichever attribute you want to select, then you can give this attribute name, and from which table you have to select, you have to mention that. For example, if I want, this is the particular table, and I am having a 3 columns, that is A, B and C. But in the output, I just want only C as an output, then I will be going to mention, this is the table name is R, then I am going to mention pi, C, then from R. This is how I'm going to represent as an attribute, and as an output it will get only the C column. Means in the case of selection part, we only in this case of selection part we used to select the tuples or records, but in case of projection part we used to select the attributes, means the column part. So this is the basic difference between the selection and the projection. In the many examinations, this difference between selection and the project operations may be asked. So this is the notation part, and we are A1, A2 and A3 are the attributes name. Over here, for example, this is the attribute name. So these are the attributes name, whichever you want to wish to appear as in the results. So rest of the attributes are the eliminated from that particular table. So this is how the projection symbol works out. This is an example. This is the relation A and B and C, and this is the particular data. Now, this is the denotation pi, A and C. So as an output, we will get only A column and C column as an output. So this is how it's going to be denote. But sometime it will delete the duplication values. So this, it can be equal to either it can be represented or either it can be represented. It will eliminate the duplicate values. That's why over here this values is multiple times. So we had mentioned only into a single time. This is how the project operation works. Now, this is again another example. If you want to fetch only account number or the balance from the account table, so as an output we will get a table in which we are mentioning the account number and the balance part as an output, and this is the account table. So this is how the projection part works. So we can eliminate the other tables. Over here they have eliminated the branch name, they don't need any branch name, so that's why whichever columns we want to see, that's why we can use that. And in the projection part, duplicate rows are removed from the result. Like in the previous example we had seen, these are the duplicate rows, so we have eliminated from the in the result part. So this is how the project operation works. Now the third symbol is third operation is the union operations. Union operation is work for the to combine all the tuples in the both the tables. So it works like that. It can be used, for example, we are having the two tables R and S, and which having the multiple tuples. So union operation will do or will combine all the tuples in the into a R and S. So this is how we are using. We can see it by the example, but the main condition is it will delete the duplicate element. Like the previous example we had seen, it will delete the automatically delete the duplicate values. Now in case of one more thing we have to be noted, that is R and S must have the attributes of the same number or the same name. These two conditions should be hold between this. Means R, for example, over here we are combining a particular table customer name. So it should be there in the first table also and the second table also. The name or the attribute should be same. This is the must condition. Okay. Now talking about the denotation part, from the U symbol we denote the union symbol. This is how we denote. Now talking about the example, we are having a table borrower. Borrow we had mentioned over here. We are having a table borrower and the depositor. So we want to combine from the both the table, we want to combine all the customer name. We want all the customer names as in of borrowers also and the depositor also. So that's why we have done pi. Pi means we want only the column part. Then we want the customer name. As an output, we will get the customer name of both borrower also and the depositor also. But the condition should be R and S must be having this attribute of the same name. The customer name and the customer name. Then only will the condition or the as an output we will get the same values. This is how we have denoted. We can combine the values. Over here also we had used the customer name and the customer name part. Then we have used this union symbol. Then we have used the another table. So this is how we have used the different table. We have combined the data or the tuples of different tables. Now in case of set intersection, it is the just opposite case of a union part, in which it will fetch the data of a common values, means which contain both the data contains in the both the tables. Suppose we are having the two tuples like R and S that we have taken already in the previous example. Now the set intersection operation will contain all the tuples that are in both. Means for example, we are having A, B, C, and in this table we are having A, B, C and D. So this is the R table and this is the S table. But in the output, what we will get, in which the data which will contain in both the table. A is containing in this table also, B is also containing this table also, and C is containing this table. But D is not in the R table. So as an output, we will get only the three values, that is A, B and C. So this is how the values going to come as an output. The same thing will be work pi customer name borrower. The symbol is just opposite of union symbol. In the case of set intersection, we had used the opposite of union symbol. So this is how we have done the representation part. Then we have mentioned the another table. The another table, like it can be any table. So this is the another example of a set intersection table. This is the first table, that is the R table, and this is the S table. In case of intersection table, it will give the common data. For example, alpha 1 is not there in the second table, so it will not come in the as an output table. Alpha 2 is there in the this table, so both the things are same and it is there in the both the tables. That's why as an output we will get alpha and 2. So this is the set intersection part in which the common data is there in the both the table. This is also the common data. This is also there the common data. So the common data will come as an output. Then we are having a set difference in which we are eliminating some data from the another table. So again, it is set difference is denoted by the minus symbol and like the difference symbol. So it is the denotation. The mainly thing is we have to notice about the notation, how we have to going to represent the data. Suppose again we are having the two tuples, that is R and S. The set difference operation contain all the tuples that are in R but not in S. Means all the values of R will be there but not in S. So this is how we are going to represent the data. Let's see it by an example. Then we will able to understand the things very nicely. This is the last example that we have seen in the intersection part. Sorry. In the intersection part, the common data is going to come. So in case of R and S, the data which is in second table, which will not come in the first table as an output, it will not come. For example, this is the common data. So it will eliminate from this table. So R portion will come, but what will not come? Which is there in the S. So it is also there in the S. That's why we are eliminating this particular values from the output. This is how we are deducting the values. Got the point? I am just taking another example. For example, R and S. We are having the values A, B, and C. And in the S part, we are having only the C value. So as an output, what we will get R minus S. As an output, what we will get C will be deducting from this table. So as an output, we will get only A and B values. This is how the set difference operation works. Now, this is the notation part. The attribute domain of R and S must be compatible. This is the condition. Now, talking about the Cartesian product. Cartesian product is used to combine each row in one table with the each row in the other table. Means it will combine all the values, all the possible combinations. So this is how the Cartesian product works. Means, for example, in the one table, we are having 3 rows. In the another table, we are having 5 rows. Then as an output, we will get the 10 rows. It is a multiplication of both the values. Sorry, it will get the 15 values. 3 into 5. So as an output, we will get the 15 rows. So how the Cartesian product works? If is in this table, it is having the 3 rows and the another table is having the 5 rows, then the output table will be having the 15 rows. Means all the possible combinations will be there in the table. That's why the Cartesian product is used. It is used to combine each row in one table and each row in the other table. So this is the notation part. We used to denote it by the multiplied sign, the product symbol. This is the representation. E cross D. E and D are the table's name. For example, this is the table and this is the another table, and we had done the multiplication part. Now let's see it by an example. This is the one table which is having the 3 rows. This is the another table which is having the again 3 rows, but the data is different. If I want to combine this particular values, then it will try all the possible values. For example, this is having the 3 rows and it is also the 3 rows, but the values are not same. See, employee ID, employee name and employee department. Over here, department number and the department name. No data is similar. So we will combine it by using the employee ID. So how it will work? This one, Smith and A department will work. A department will work in this marketing, sales, and the legal. This is how the data came. Can you able to see this? Yes. Now, again, we are having the A and B and C also. Then we will take as an output second value, Harry, and department, employee department. Then we will take again three values, this, and marketing, sales, and legal. So we will try all the possible combinations. The last one is about the third, that is the third zone B. Then we will take again the possible combinations, means we will take all the three values over there also. Then we have taken all the three values of the marketing, sales, and the legals. This is how we have done the representation of the Cartesian product. So in the case of output, we are getting the 3 cross 3, means the 9 rows as an output we will getting. This is how the 9 rows we have got over here. So this is how the Cartesian product works. This is the very important operations used in the relational algebra, and which is denoted by this particular symbol. Employee X department means we are doing the Cartesian product and we are combining each row of one table to the each row of the another table. This is the another example of a Cartesian product, 1 and 2 table. This row, this table contain 2 and this table contain 4. So as an output, we will get 8 rows. We will do the multiplication part. So this is over here, we are having the 8 rows. We will try all the possible combinations. They are the various composition of operators. We can use the multiple operators at together like this. We have used the both the things. A should be equals to C, and we have to combine the thing also. So we can use the multiple tables also. One more another important operation is that is the rename one. Rename is used to rename the output relation. For example, we use the row as a symbol, as a denotation part. Row is the symbol. Then we use the new table name. New table name. Then we can use the old table name. So this is how we have done the table. Firstly, the table was named as the student. Now we had mentioned to the student one. We can rename it to the student one. So this is how we have used the rename operations. So these are the various operations of the relational algebra. One more is the division part. So these are the various operations which we used in the relational algebra. This is the one example I'm going to take, because the question used to come by using these examples only. So for example, this is the schema. Means this is the schema where we are having the tables, branch, customer, account, loan, depositor, and borrower. These are the attributes. This is how the question came in the examination, in the GATE examination, in the STs and PUTs, whatever the examination, it came like this. So we have to find the values, find all the loans of over $1,200. So we have to give the condition used in the relational algebra. So this is how we use sigma. We have to find the amount should be greater than 1200 and it is from the particular table. This is the selection part, sigma, predicate, and the R part. So predicate is amount should be greater than 1200. So this is how the question used to come. In the case of this, we have to find over here we have to find all the loans. That's why we have taken the sigma part. In the case of over here, we have to find the loan number for each loan that should be greater than 1200. So we will give the condition like this. We have to find only the loan number. We have to find only the column from this particular data. So that's how we have noted over here. That is the pi loan number as an output. What we have asked, that is the loan number. That's why we have taken pi loan number, and the condition was the same because the another condition was also given over here. So this is how the example comes and the question can be asked by using the relational algebra. Thank you. Jai Hind. We will discuss the next tuple relation calculus and domain relation calculus in the next lecture. Thank you. Jai Hind.